we're doing right now.
Half hour.
Half hour on Tcl tools for game engines in CAD. So I think I was planning on doing a quick little demo of using all these nifty new build tools to create a shrink-wrapped executable. We could walk through it if anybody wants, or if somebody's got some really cool stuff that they want to talk about, because this is more of a panel than a talk.
This is like package potpourri, or?
Yeah, gluing. Wait, that's not so for another half hour. What am I up here?
No, we're ahead of schedule.
Oh, we're ahead of schedule. Great. All right.
We know that's unusual at a Tcl conference, but it happened.
Okay.
If you want to talk to me, we will ask you.
Okay. All right. So this is the type of use case where I hope that we can make the new T more of a friendlier user experience. Now, I'm still putting the covers on all of this stuff, so it doesn't quite look as neat and as tidy as the final version would be. But there's the makings of stuff that is recognizable as quite possibly a makefile at dusk with the light behind it. So the first part is here. My project uses a lot of stuff from Tcl'2017 and Odielib, and so because my makefile is just a regular Tcl script, I can call all of those packages into my build environment so that I can make use of them while I'm building the rest of my package. And that's separate from what's going into the final executable. So because I've got a full working Tcl, the sky's kind of the limit on what we can do with it. So there's bits of all these packages that I want to make sure are there, and the toolbox has facilities here. This is a practical local tool. So I've got several key things like Tcl''lib, Tcl', that it just knows how to go out to the web and grab and unpack them in a location that you can look up. So that if I wanted to grab modules from Tcl''lib, I could. So here what I'm doing is I'm taking a list of tools and a file that tells me if they exist or not. And I can look to see, is that file there? And if not, grab that external repository and save it side by side with my application so that I can just pull the source code from there. And I don't know if you guys have taken apart somebody else's code, you find out that half their stuff is a scale copy of things from Tcl''lib, including the test files and the documentation. This gets us away from that. It's a more of a, you can just grab all these tools that the community has and you just have to worry about what you're doing with your project. Now this file also defines some build targets, and this is bits and pieces that I stole half-assed from Estimate. So these targets are actually Tcl objects that have rules about who's depending on who and what actions that the user asks for should trigger other actions in response. So we're not doing anything yet, so much as we're defining 5 build targets: Tcl', a base kit, packages, the name of the product itself, and an extra one, which is just clean up everything and start over. This command here is a utility that takes a list of arguments that the user has put on the command line and execute the triggers. So if I want to build my kit, let's see, I can just call in with in the operating system Tcl shell, make dirt kit for all, and my program is there. And this is just a little text adventure game that I'm trying to write, and of course all the command line features are broken right now because I was in the middle of a major group right when the conference happened. But the idea here is that this is going to be a HTML text adventure game, and I have bindings for when the user clicks on things, it should cause the screen to refresh. If this was a canvas-based game, I would call that into play. But it ships as a single executable. And as you saw, there wasn't much to putting that executable together. It is, there's some recipe stuff, and when I get a little better at figuring out what the use cases are, we'll have some canned routines for this. But here are some cross-platform instructions for building Tcl'2017 statically. And here are instructions for taking packages from, if you remember, I had that ini file. This kit also has a list of packages that it wants to come in contact with. Well, here is the list of instructions for getting all of those packages, compiling them, and putting them where I can link to them when I go to create my final executable. And you can see I call an object into being. So I get a list of packages, and I'm just using a method for those packages to take care of the whole mess of download it from the web, drop it in some location, run through AutoConf, build the final product, put it in some place where my linker knows it can find it. And then that same object can also handle messy things like a lot of projects have not just the library, but they also have Tcl files or image files or whatever that need to be installed in your VFS so that the package has all the pieces that it needs. And so there's a mechanism in there to handle installations to a known location. Instead of installing it to my local environment, it's installing it into the VFS. And where that VFS exists, because this is an OO object, it's all here in the configuration file that I built. Let me bring up the base kit ini file so you guys can see what's going on. And why I can't remember my font, I don't know. So here it looks kind of like there's some AutoConf goofiness going on, and that's exactly what's going on. This is the sort of configuration and hinting that you would see at the top of a make file. But we also are running inside of our base kit object, and we can do things like add a dependency on a project, in this case the Tcl core, or add a dependency on SQLite. And I can even say, well, for development, I just want this fossil branch, but if I'm doing things for production, I want this fossil branch. And it's designed to work on a source level, so I'm not pulling binaries. I am pulling the actual source code from the repositories for these projects. And because I can tag exactly which release I want, it doesn't matter what the distribution mechanism for that project is actually doing. I can lock myself in whatever moment of time works for me. Each of these packages also has some properties. It usually just works with give me the name of the package, possibly even the version, but you don't have to do that because part of the process of downloading it and running AutoConf pulls out the actual package name and actual package version of that checkout. So I don't have to know that information ahead of time. The toolkit will go in and find this information for me. So all I need to know is roughly what's the name of the init function, because this keyword tells me for the product I'm building, this is going to be statically linked into my executable. And because it's going to be static, I need to know what's the name of the init function for this static library that's going to become part of my final executable. I'm basically trying to figure out how you guys are going to do it by making myself go through the process first. And all of the packages you can see follow roughly the same template. So what you learned to configure one kind of carries over to other ones, and there's nothing really exotic about a lot of these packages that are usually a giant pain in the neck to figure out all their quirks. The only one that I've got some special handling for is Tcl'2017, and what I do is I actually can modify the object by replacing the instances method with my own. So for SAC variety of projects, which use that install.tcl file, I have a set of behaviors that just work out of the box. But for Tcl'2017, I'm picky about which modules I want. And so this allows my installer to have it, basically have better control over what's going on when I pull packages from that other repository.
I haven't seen it.
Okay. Well, this will be announced about source.
And
Jeff Rouse.
it also does nifty things like
at my own office.
there are these packages here that are just huge, and I don't need them for my project, so I filter them out.
And so his reply went there, and that's.
This is actually
it was
calling
up roughly around 11.
Tcl'2017's own installer. So, usually I don't actually have
to say something
write
off.
a handler. There are a bunch of really nice tools out there. Because I'm using exec to do a lot of things, I can make use of decent, sane installers where they do exist for a lot of these sub-projects. And here is a nifty one. I am actually using Tcl'2017's own facilities to take all of the C-accelerated modules in there and compile them ahead of time so that I can package them with my own installation. So there's going to be a Tcl'2017 shared library that I am going to include in with my own thing to accelerate all the Tcl'2017 stuff. And the idea is that I'm going to give you guys one good automation language with a lot of powerful tools so that a Tcl programmer or a decent C programmer will be able to at least walk their way through examples. Now, what I'm doing here is you see that there's no actions going on, because all I'm doing right now is building a configuration. I'm building objects that will go off and do actions later. This is just strictly configuration at this point, and in fact, this isn't even a complete configuration, because a lot of these objects will go out and learn more about themselves as they walk through the installation process. All right, so back to me. So one thing that differs from other make-like systems is you don't see any instructions here for what to do, just the relationships. I build an array that tells me what parts of, I think of it more as a script with templates and slots. And so I just test to see, all right, am I doing a disk clean? Rather than put the instructions for a disk clean up here, I actually allow the script to walk through, because in some really complicated cases, your procedure may need to have one other part of the process come in about halfway through, and then it needs to come back through and do its own thing to clean up. So I'm not sure I'm completely sold on the approach. I'd love your guys' feedback on whether this is just completely insane, or what we would actually like to see in a make-file replacement for Tcl'. I personally like it because, for me as a script writer, I like to start at the top of the file and see the actions play out as I move down. It's a different mindset from a typical make file, where you have the build target and you just kind of have to work out in your own mind what's going on, how, and when. But for when I was developing things, I was finding this worked out really nicely, because I don't have to worry about chains of events firing off. I just flatten that all out into a series of trues or falses, and then those trues or falses can guide the script in a nice linear fashion. Installing all the sub-packages is just breaking out a list of them and calling out compile, and we already ran through that. And then, my final base kit is actually the C code implementation that is built on the fly by the system. And it's just calling a method inside the base kit object to say, okay, at this point I want to build my, not my table shell for my static table shell. I want to build the static executable that's going to be all of my packages, just without my VFS so far. And then down here we provide facilities to wrap our final executable. And the wrap mechanism not only takes this virtual file system that we're building with this, copy function here, it also grabs all of the constituent bits of Tcl and Tk that the init is going to need, and make sure that they get into a prearranged location in the VFS. So, 133 lines to do what AutoConf used to do for us, and you don't have to you don't have a lot of cargo code to make file. Yeah, actually this project doesn't even have a make file. It's all just Tcl. So, any comments so far? Yeah, so I go ahead and blank this all out. I can start with an empty directory. I'm not actually in my source code. I like to build a separate directory. So if I want to start all over from scratch, I have my code checked out here. And it will go out and grab the extension. Now let me just go ahead and show you that it will pull a package if I don't already have everything checked out. So what I do is all of the packages are checked out in a directory above. Well, basically the same directory as my file or git checkout. I have all the packages unpacked in that same directory. I call it the sandbox. And that's so you don't have to worry about, working through Git's way of pulling a sub-project or Fossil's way of pulling a sub-project. All projects are equal. Nobody's in anybody else's directory structure. All right, so I'm going to yank SQLite and start this process over again. And you'll see that Canvas 3D, there's nothing built in that directory. This is all just the pure source. All right, so we're going to, so my make file can run, and it will figure out all the pieces it needs. So right now what it's doing is it's doing a fresh checkout of Fossil with the Fossil tag that I wanted for my particular project. And it's going to go through for each of my projects, unpack them, do a configure, do all the making that it needs to do, possibly patch the code if I've got something really wonky that I need to modify the source or something along those lines. And then let me get out of this and show you guys what's going on behind the scenes. So as it's going along, each of my packages is actually, the build process is putting a subdirectory in here, which is all of what that package is producing. So if I look at package SQLite, I'm just going to see the final make file, the final static library, a little log of what Practical did with it, and any header files that are generated on the fly. Some packages, for instance Odielib, actually produce parts of their C implementation as part of their make file. So I've covered a lot. This thing should be just about done. Do anybody have any questions so far? Oh, and we can see now that we have our dirt kit. And it worked from bare metal to a fully working thing in the time it took me to explain what the heck was going on. So basically we had nothing there, and we now have, we walked through, linked a whole bunch of different packages, and built a brand new static equivalent shell. And let's see some more features going on here. In my directory, you'll see that there's a couple of C and H files in the build directory. These are actually parts of the implementation that were built by the practical toolkit to do all the connective tissue for this project. So if I look, why can I not remove font size? There's a lot of header files at the top, but they're all blocked off in one spot. And you see a lot of comments telling you, well, what part of the practical process was building this part of the file? There's some cargo cult code that every project needs that we just include. I didn't have to know anything about it. I just had to build my own in my main. This has built all of the other parts of the project. It figured out all the init functions to call. It knows how to wake up Tcl stubs and TK stubs. It knows how to build a main hook, which is how we, this is not built with core zip VFS. This is doing it the old-fashioned way, where I hijack part of the Tcl boot process to tell it where init's going to be. So this package knows how to build a well-behaved system, and I can take this same project, go over to Windows, and run Tcl shell make, and it will do the same thing, but with the Windows variety. So that's what I hope will, that's mostly what I was going to talk about with gaming and trying to make these things work well. We've got a lot that Tcl can offer if you know that the tool is there, and the easier we can make it to provide these tools, the 3D canvas, the HTML widget, the core itself, and not have to know about a pile of computer science to make it work, I think that's going to be a pretty powerful comment. All right.
So one of the things Make gives you is incremental building, where you make a small change and it figures out the minimum to reconstruct to get you back to a test case. It doesn't seem like this is doing that. It's not set up for incremental kind of kills, or is it?
Well, it's actually, at points, calling make in the background. So not all of my extensions are practical savvy. So if I go look at, it's actually, when I go to build the packages, it's running make. And so SQLite, because I didn't modify it, doesn't recompile. If I wipe out the O file, here, I'll do a, so make it once. You see that all it did was wrap the executable. If I remove the base kit, it's now re-implementing the base kit and recompiling. If I wipe out the Tcl file, I don't quite know how it did that, but somehow managed to link everything without it absolutely puking about the fact that SQLite wasn't there. Although I think it may be in the background, huh?
You have a lot of unresolved work.
Yeah. So I wipe out the package directory. Now you'll see it do a fresh checkout. All right, so I'm getting the time warning here. Does anybody have any other questions? And then we can do a work in progress, or if you just chat with me.